Okay, time for module 3. Hope everybody's still with me, and I
Yes,
hope
we are
every.
here.
Okay, good. All right.
I have a. Can we ask questions?
Sure. Go for it if you
Can
have
I
a
ask
question
one
now.
question?
Sure.
Yeah. So when you are selecting the type of distribution, as we did in the example before, is it possible to give the data in Excel file and ask CMU to identify the type of distribution?
Yes and no. So I think what you're referring to is a data fitting type of technology, and we do not have that data fitting built into Simio because there are a lot of commercial products that do that very well. But what we do have in Simio is the ability to use the data tables that I briefly talked about, and you could import your raw data into a data table and then sample directly from that data. Now, depending on your application, some of you may have heard of Dr. Barry Nelson. He's one of the leaders in statistical analysis within simulation. And he's done some work to basically say that in some cases you get better results by sampling directly from the data rather than converting it to a distribution and then sampling from the distribution. But a lot of that depends on how much you know about your data. But I don't want to go into that any further right now, but we do have the capability to do that.
Thank you.
Okay. Any other questions before I resume? Okay, so where we were at, we were talking about randomness and random in, random out, and generally the fact that doing a single replication and making results based on that is generally not an actionable thing or not advisable. Instead, Simio has a technology called experiments that allows you to do that in the software. And just like in weather forecasts, and I misspelled forecast there, but just like in weather forecasts, the way they generate weather forecasts, they don't just do a single trial and say, oh, that's the weather forecast. Instead, like, for example, when they're trying to project the path of a hurricane, they might do hundreds or thousands of different scenarios and then take the average of those, and those are represented in those cone charts that show as the data gets farther and farther out, the prediction cone gets wider and wider. In Simio, we do a similar thing, is we use the experiment feature to do multiple replications of one or more scenarios with proper statistical analysis. And so let's go into the software and see what that looks like. Let me start by just with a slide of it. Is we're going to go into the experiments, which if you want to get ahead of me here, you can right click on model and say, choose new experiment. And when you do an experiment, then you'll go to a different window with a different set of tabs like this. So you can see here we're in the experiment window. And so this shows by default, I have a scenario named scenario 1, and you can change the name as much as you want. And the replications defaulting to 10 replications, and you can change that default if you want. And then this is telling me that at the moment, I have done 0 replications. If when you first go into this window, you'll also see a properties window up here, which is the properties of the experiment. And the properties of the experiment shows you things like the warm-up period, which defaults to 0, the number of replications, the confidence level I want, and things like that. So I'm not going to go into explaining these at this point. except to say that those are important, and of course they would be covered thoroughly in a full course. Okay, so let me go back into the software here. By the way, I was ending with a question here of, so did everybody get the same result? And I would guess that everybody got different results than this 7.19. And why would that be? The most common answer I get is, well, it's random, right? Well, actually, it's not. It is pseudo-random, which, if there's ever a contradiction in terms, or a, what do they call it, an oxymoron, it's pseudo-random means it's predictably random. In simulation, we want predictable randomness, because if I run this again, if I stop and fast forward again, I want the results to be the same, because I want to look at, and if it was truly random, it would give me a different result every time I press run. So that would be kind of hard to debug, if I, or even to analyze the system. If I run it for a while and see an interesting situation and I want to delve into that a little bit more, how would I do that? Well, if it's truly random, I couldn't. But because it's pseudo-random, I can. And I'll explain where we actually get the randomness at. But so back to the question, why is this not the same as what might be on your screen? Well, it's not because they're random. It is because we have different models. You say, well, I built the model just like you built the model. Well, did you? I placed my source at exactly this location and my server at exactly this location, and I don't expect you to do this, but if you go into the path general physical characteristics, it tells me that my path is exactly 2.57 meters long. Was your path exactly 2.57 meters long? I would guess not. And if it was, I'm guessing that your second path wasn't exactly the same length as mine. So we actually have different models because it takes time, a different time for an entity to go 2.57 meters than 2.58 meters. And although that might sound different or minor, in fact, that things arriving at different times could actually cause different random numbers to be pulled, and then it goes from there and gets more and more different as we go. So what can we do to make our models the same? Well, you could go through and try and reproduce mine exactly the way I did, but an easier way is I'm just going to say, well, the path length is not significant to this problem. So I'm going to change my paths so that the path length doesn't matter. Now, again, make sure that you have stopped the model. If you haven't stopped the model, then you won't be able to do this. But I can click on path one, and I'm going to show you a new feature, is that I can control click on path two and control click on path three. So that's known as a multi-select. So I have three things selected at once. And now if I wanted, I could go over here and change anything about all three of those at once. But what I'm actually going to do is right click on any one of those. And down in here, I'm going to say convert to type connector. So remember, we had 4 different types of links that we talked about. And the connector is a link that has 0 time transfers. So if we make them 0 time transfers, then it doesn't matter how long you do the path, it still takes 0 time to get there. So I'm going to change these all to connectors. And so now you'll see connector 1, connector 2, connector 3. So again, just a quick review. I hit stop first, and then click on any one of the paths, control click on the second one, control click on the third one, right click on it, select convert to type, and in this type I did connector. So now if we run this model, if I fast forward this model and look over to the results tab, I now get 7.2952, and I think all of you should be getting the same 7.2952 unless you did not change unless you did not make one of the other property changes that I had specified. Okay, so we should all have the same model at this point. And now that we all have the same model, let's go over to the experiment. I just right-clicked on model up here in the upper right corner and say new experiment. And so now you'll see it created a category called experiments, and then it created something called experiment 1, which you could name to something else if you wanted. And here's what I said before. We have by default 1 scenario run with 10 replications specified. If I wanted to specify 20 or 30 or 55, I could do that. And over here, as long as I haven't touched anything up here, it's showing the properties of my experiment, including the fact that I have no warm-up time, default replications, etc. Okay, so if I just run now, hitting that same run button that looks like a fast forward, because it basically is a fast forward, it's going to run 10 replications of that model. And you see it ran that fairly quickly. And in fact, it ran them more or less all at once. So I have down here in the trace window, it tells you what it did. So it ran, it tells you as the replication completed, it tells you that. So it completed replication 2, and then 4, and then 6, and then 3, and then 1. You know, what's going on with that? Well, what's going on with that is I have a dual threaded quad processor machine, which basically says I can run up to 8 replications. I have 8 processors available to me, and so I can run up to 8 replications at a time. And so it spun off replications 1 through 8, ran them, and then as soon as it finished the first one, which happened to be replication 2 finished first, then it spun off 9, and as soon as it finished the second one, it spun off 10. So you can see that's a feature that Simio has that allows you to take full advantage of your processors to make as many replications as you want at once. So now, why did I run those replications? Well, because now over here in my pivot grid, so back under the pivot grid, I have more information about each one of these. Where my first one, I forget the number, I think it was 7.1 or something like that. It just had a single prediction. Well, that was a single prediction like my prediction that, you know, I'm going to roll a 7. I got a 7 once, so I go spend my life savings on it and lose it. Well, I don't want anybody to lose their life savings on a single prediction. So in this case, we're saying, well, I ran 10 predictions of it, and the 10 predictions, the minimum was 4.4, the maximum was 7.3, the average of the 10 was 6.07, and the half width was 0.73. The way you might read that is in my properties window, I had a confidence interval specified as 95%, and most people just leave it there. And so one way of reading this is my average predicted number in system is 6.07 plus or minus 0.73. And I'm 95% confident in that. So let me say that again. I am 95% confident that my average number in system is in the range of 6.07 plus or minus 0.73. Now, how do I know when my answer looks like that? How do I know when I've run enough replications? Well, look at, you know, not all of these are going to be key performance indicators, but let's just say that number in system was one of my key things that I wanted to predict. And I want to get that predicted within 0.5, for example. So I'm good enough, you know, to say I want to know within a half of an entity, you know, what my prediction is going to be. Well, this says I'm 95% confident within 0.73. So that's not within 0.5. So it says, well, I need more replications to get to where I want to be. So maybe I'd do 15 or 20 replications. And as I do more replications, I'll get to that point. So let's do that real quick. Let's go back and say, actually, before I do that, I'm notorious for a bad memory. So this was 6.07 plus or minus 0.73. See if I can remember that long enough. So if I went to 20, for example, and note now it's already got 10 done, so it's just going to do 10 more. It's not going to do 20 more. So now there's the 20. And 6.64 with a half width of 0.76. So that didn't actually make it any better in this case, but in most cases, as you run more replications, your half width will go steadily down. But we'll see that again in a more realistic model a little bit later. Okay, so this is all well and good, designing, just running experiments and getting more results. But what if I wanted to look at particular results? If I had something that was interesting and I don't want to go directly into that pivot grid to get it. Well, what you can do is add responses in your table, and you can name those responses to be whatever you want them to be. So if I go back to my design window within Simio, open this up again here, and I can add a response. So responses will show up here in the design window. So I want to add a response, and let's say the response that I added or that I want to add is utilization. So I might say utilization on server 1. So you can type anything you want there. So that's util server 1. If you want to make it prettier, you can make it prettier down in the display name. And then I'd put my expression. So what might my expression be? Well, again, I can use the pull down window. And the pull down window, starts with generally what object do I want to select? Well, this is something about server 1. So I want to go down to server 1, dot. And then if you went back to that slide that I said was a really important one, you might want to remember that it had, some of the most commonly used things. Well, one of the most commonly used things is under the capacity keyword. So I hit capacity keyword and dot. And then what I want here is scheduled utilization. So I went down to scheduled utilization and hit enter. So there's server1.capacity.scheduled utilization. And so that will give me what I want. Now, just as a shortcut and to illustrate that you can do it, although that wasn't hard to do, if I didn't want to go through that for the next one, I can highlight that, hit Control C, and now accept that. And so there's my server 1 capacity. Now I go up and add another response, and let's say I want to do a response for utilization of server 2. And now in here, I can just hit a Control V, copy that expression in there, and go back to the beginning where it said server 1, and just change that to a server 2. Now I know this is, some of these things are doing a little bit quick, and I apologize. I wish I could look and see everybody's face and see where you're at and where you're tracking, so I'd know when I lost somebody. But since we're trying to cover a lot here, I'm just kind of moving along. But as a review, then I went up, I added a response, and I did that twice to give me 2 columns. I went into the first one and typed util server 1. And then for the expression, I used the expression editor to do server1.capacity.scheduled utilization. And then I did a shortcut of taking a copy and paste of that to my second response, which was server 2. I just pasted it in here and changed the 1 to 2. Let's add one more on here, add a response for time and system. That's a common thing that people want, and I'm just going to call it TIS for time and system. For time and system, what object are we looking at time and system for? And there are actually, for those of you who know a little bit more about Simio, there's actually two places where you can get a time and system. But let's go to the more expected one, I guess, would be default entity. So on the default entity, I want to say, well, the only thing here on my list is the population of the default entity. So I select the population of the default entity, which says I want to look at all the entities, not one particular entity, and then hit a dot and say time and system. And time and system here is not bold and has a little arrow at it. And those two things are a warning to you, or an opportunity for you, in this case, a warning that you can't stop there. If it's not bold, it means Simio doesn't know, it doesn't have enough information to do what you want. So if I put a dot there on time and system, if I just stop there, it would not work. But instead, I have to tell it, well, what is it about time and system that I want? And in this case, I want the average time and system. So I hit enter, and that is sufficient. Now, the one other thing that we want to do here is specify that, well, time and system is actually a time. If we don't tell Simio it's a time, then Simio will treat it like any other number. But in here we can say, well, it is a time, and just for chuckles, let's put time in minutes. So we're saying, well, we want to have time and system displayed in minutes. Okay, so everybody with me at this point? Now, this is information that is in the pivot grid, but not yet not displayed here. To get it to be displayed here, we need to rerun those replications. And just for expediency here, I'm going to set my replications back to 10. So my required replications back to 10, just to make this run faster. I'm going to reset, which clears out the data that was already there, and then run it again. And there's my 10 replications saying, based on 10 replications, my average server 1 utilization is 82%, my server 2 utilization is 69%, and my average time in system is 14.82 minutes. Okay, let's see where we're at now. Okay, I'm not going to actually illustrate this, but I'll just talk about it, the fact that we could do it. In responses, your responses don't have to be simple things, they can be expressions. And so this is an example of if I wanted to have a throughput that was expressed in units per time unit, then I could go off of the sync to tell me the number of entities that went through the sync. So that's how many entities entered the sync or left the system. So I could say that divided by time now, which is how many hours did I run, that will give me the number of units per hour that we produce. So that would be another example of a throughput. Okay, so the responses do several things for you. Experiments do several things for you. Experiments, let you do multiple replications, let you do multiple scenarios, and also let you evaluate responses graphically. And those are specified under response results. And so if we wanted to look at the response results, well, before I go back to the software, so this is what we refer to as a SMORE plot. So MORE is an industry term called measure of risk and error. So that is common in, well, it's not common, but it is available in some simulation products. The S on that is Simio's version of it. So Simio measure of risk and error. And there's really nothing shockingly new on here. The only thing that's perhaps new is the fact that we've combined all of these things into one chart. And so basically we have, kind of a box and whisker chart that has the mean represented as the gold dot, with the gold area being a confidence interval around the mean. And then we have our upper and lower percentile, which was specified on our experiment properties as to what we wanted that to be. The minimum and maximum observed value and the confidence intervals around those upper and lower areas. So if we go back to our model and now say, look at response results, there's our response results on server 1. Not real interesting, but if you hover over things, it'll tell you, the mean was 82.54, and this gold area was the confidence interval around the mean. It also gives you the mode, which was a little higher than the mean, and the range of the operations. We can also look at server 2 and at time and system. So you can see how each of those looks. Now, the power of this is not in evaluating one scenario, but it's in evaluating multiple scenarios and comparing to each other. So how do we get to multiple scenarios? Well, that is by something called reference properties. And so in our model here, we want to put in, let's do some experimentation with this to say, well, how many buffers do we want to have, or how many weighting areas do we want to have in this model? And where should we put them? So let's say someone has decreed that you can have up to 7 weighting areas in this model. And it's up to you to find out where these are. So maybe these weighting areas are really expensive, or they require an expensive fixture or something like this. So you've got to figure out where to put your 7 weighting areas. And how do we do that? Well, if we go back to the model, and so now we're looking at the experiment. In the navigation window in the upper right, if I click on model, it takes me back to the model. And you can see the tabs across the top. If I want to go back to the facility window, that's the facility tab. So I click the model in the navigation and then the facility tab in my model. And you can see in my model, basically every place where there's this green line, and I'll zoom in a little bit so we can see better. Every place where there's a green line, that is a place where entities can potentially wait. So on the output side of source, I've got an output buffer contents. On the input side of server 1, I have an input buffer contents. Not strictly a waiting area, but I have a processing contents where it waits while it's processing, and then I have an output buffer contents. And I have the same thing on server 2. So I'm going to just take a quick shortcut here. I'm going to highlight server 1 and highlight server 2. So I clicked control click. So now anything I edit over here, I'm editing both of those at once. And just to simplify the problem here, I'm going to set the output buffer to 0 on both of these. And let's set the input buffer to 0 on both of these. And I'll click off of that. So I've set input and output buffer to 0 on both of these. And then over on source, I also want to set the input buffer to be here. Let's just call it 1. And again, there are reasons why we want to use a 1 here that I'd rather not get into in this short session. Okay, so now I have a place to store one entity here, no entities anywhere else except in the processing buffer. And just so we can see the results of this, I'm going to add another one of these pie charts above server 1. So I'm going to move this a little bit out of the way here. And then server 1, I'm going to do status pi. Oops. And again, I'm not clicking on status pi, the word. I'm clicking on status pi, the pull down list, resource state, and then drawing a pie chart for that. And let's just because I'm an engineer, I'm going to bring them up and make them about the same size and beside each other. Okay, so let's run this now and see if we get anything surprising. So I'm just going to run. Oh, what happened there? Is anybody see that yellow signed up? That yellow indicated, I'll see if I can pause it when it next happens, but it goes pretty quickly. Oop, nope, didn't happen. But what happened was the entity was on server 1 and it finished on server 1 at the same time there was still an entity on server 2. And so when that happened, the natural occursion would be this entity would move to the output buffer, which we have set to 0, and then try to move to the path, which we've set to a connector, which is instantaneous movement, and then try to move to the input buffer of server 2, which we've also set to 0. And so since it could not move to any of those 3 places, it sits here and blocks the server. So even though it's done, it's not going to let anything else process the server because it can't leave. So that's the problem that we get with this with no buffer spaces. So I'll let it run again. Okay, so obviously 0, 0, 0, isn't the right combination. So what might we want to do? Well, we can put some expressions in here. So if we click on server 1 and then right click on the word capacity under input buffer. So I'm going to right click on the word capacity under input buffer, and you'll see that there is a set reference, create new reference property. If I click that, then it allows me to name this to be whatever I want it to be. And so I'm just going to call it S1 capacity, server 1 capacity. And you can be as verbose as you want. And then I'm going to go into server 2 and do the same thing. So I clicked on server 2, right click on capacity, set reference, create new, and you can see I could reuse S1 capacity if I wanted. I don't, I want to have a separate capacity here. And so I'm going to create new reference property and in here call it S2 capacity. I apologize if I'm going a little bit fast here. So I have server 1 capacity, server 2 capacity, and if I click on the background of this interactive window, you'll see I have this new controls area set up here that has S1 capacity and S2 capacity. So now if I wanted to compare those, I could say, okay, we'll put 1 in each one of these and run it again. And now you should see there are entities waiting here and waiting here. So I'm no longer blocking the server. So I've increased my throughput. Okay, so what is the right number to have? So in that case, you saw it block there because this capacity was full at the same time that was busy. Okay, so let's go back over to our experiment and say, well, so where do I want to put my 7? Note that now I have controls are automatically showed here with the default value, which was 0. And so I can put any number of scenarios and controls that I want here. I designated 1 waiting area at the server, so I have 6 more to go. So I could do this as verbose as I wanted to, but let's say I put 1 here and well, we might as well use, actually, let's use all the ones we have. So 1 and 5, or 2 and 4. And if it's not obvious, I just click down below where I want to be, and it creates a new scenario for me. So 3 and 3, or 4 and 2, or 5 and 1, or 0 and 6. Okay, so those are my scenarios, and let's make that, oh, sorry, I got the last 6 and 0 should be the last one. And the first one should be 0 and 6. Okay, so there's my different feasible scenarios, how I can use 7 buffers, again, remembering that we allocated 1 for the source. So if I wanted to run these now, I could run these, and let's run my scenarios, and there's my scenarios. It's again using all my processors. So now it's got 10 of 10 replications in each one of these. And now if I look over to my response results, that tab up here next to the design tab, it will show me for, oh, did I not rerun? I think I did not rerun the first one. Yeah, here, let me just get back to this. So since I can rerun it quickly. Okay, so my response results. So this is looking at time and system, let's utilization of server. So if I was looking just based on utilization of server 1, now you could look at this and say, well, which one is the best? Now, I won't actually, maybe time and system is a better overall. Let's see. So this is telling me, actually, I should do the one that I had planned on doing, which is throughput. Let me add one more item here. I'll add a new response, and this response would be throughput. And I would say throughput is probably the best measure on this particular one. And my throughput I could get from a couple different ways. I'm going to get it, as I showed you in the last slide, off of the sync. So I'm going to do sync1 dot input buffer dot number exited. So how many have exited sync1? So that's a count, and I'm going to rerun this again. I reset it and rerun it. So I want to look at throughput as a result. Okay, so now if I look back at my results and look at throughput, see something a little bit more interesting. So what is the right answer here? Well, assuming higher throughput is better, you might say scenario 5 was the best one because my throughput was a little bit better. But what this chart is telling you is that whenever there's a confidence, now remember the way to read this is to say the confidence interval of this is between 522 and 545. So I'm 95% sure the right answer is between 522 and 545. But if I look at this one, it says, well, this is between 519 and 537, meaning there's a lot of overlap between there. So I can't say with any statistical validity that scenario 5 is better than scenario 6 or better than scenario 4. So if I look at those three and say, well, those three are all good candidates, but those are really the only good candidates. So I can get rid of scenario 1, 2, and 7, and maybe even 3. So let's go back to my design window, and I'm going to click on 1 and then click again. So the interface is kind of funny that you have to click on it once to get focus and then again to check it. So, or uncheck it in this case. So I'm going to disable those 3. And then the others, I'm going to say, well, I'm going to skip a step here. Well, let's do 50 replications because I want it to be more accurate. Actually, I'm going to do 100 just to give me time to talk while it's going. Okay, so if we set that to be 100 replications of each of those, and I've said I wanted to ignore it, if I go back to my response results, now it ignores those 3 that were clearly not contenders. But what am I going to see when I run this? What I want to see is as I run more, I want my numbers to get more accurate and my confidence interval to be reducing. And so I'm running now. And now as you see it running, now the results are getting more and more accurate. And you can see that my confidence interval is getting smaller and being less overlap with the other ones. So as I run this more and more, now at some point I will be able to say that scenario 5 is statistically much more accurate to be the better one than either scenario 4 or scenario 6. Okay. Okay, so very quickly, so you saw that was a little bit of a tedious process. Simio can also automate that by using a product called UpQuest. So UpQuest basically replaces that trial and error that we just did. Now, in this case, there were only 6 or 7 different possibilities. So if there's only 6 or 7, you know, it doesn't save you a lot of time to have it automatically generated. But if let's say, you know, I had a choice of 50 buffers, and so any one of those could have a value between 0 and 50, I could do that, and UpQuest would just automatically do that for you. And what it does is it uses taboo search, scatter search, integer programming, and neural networks to basically determine what is the best choice of scenario to try next. This is actually a result from a real project. And you know, to most people, this looks like just a random set of numbers, but to me, it illustrated exactly what I've been telling people the way UpQuest works. And that is, it is a very aggressive algorithm that the first thing it does is a very aggressive drive towards a minimum. So it will start by doing some exploration to learn about the model. And then after it learns about the model, it says, well, gee, I know that when I change X, my performance goes up. When I change Y, my performance goes down. And so it's going to use that information to have a very aggressive drive towards a minimum. Now, this might not be the minimum, but it is generally, you know, in running a relatively few set of scenarios, it will come up with a very good answer to the question. Then the only way you can tell that there isn't a better answer over the next hill is to go over the next hill. And so, OpQuest will essentially go over the next hill by going uphill and trying some things that it doesn't think are good in hopes to find something that is better. Now, in this case, it was not better, went over another hill, and in this case, it found something close to the good, but not better. And so it will do that until it evaluates all of the likely scenarios. And then after that, it will just continue searching for the best by searching all of the unlikely scenarios. So note that the results have gotten steadily worse out here, but the only way you can prove optimal is by trying every possible scenario. But without trying every possible scenario, OpQuest usually gets to a very good scenario fairly quickly. And so, and it will actually skip scenarios that it can determine upfront are infeasible. So you can see that although in this particular one there were 152 possibilities, it only checked about 100, and it actually got to the good one after about 20. So OpQuest is a really valuable tool when you're trying to do things, and this kind of explains some of the other things that are available on it. Okay, I'm going to skip past that and go into a little bit on success tips. So success tips are basically how do you assure a successful project? And one of those is, recognizing who determines success. Is it me, the modeler? Is it my boss? Or is it the stakeholder? And I would suggest it is the stakeholder, the consumer of this model, who determines whether or not this is a successful project. And we start by determining, well, what are the objectives of the stakeholder? What do they hope to get out of this model? And quite often a project begins with, what do you want out of this? I want a model. Well, what do you hope to learn from the model? Well, I'd like to understand my system better. Okay, well, that's valid, but not sufficient. So what is it about your system you want to understand? Well, I want to understand where I can best allocate my buffers, or I want to understand why is, where are my bottlenecks and how can I fix my bottlenecks? Or whatever it is important to evaluate what the stakeholders' objectives are and determine, what they want to evaluate, learn, or prove. What is the scope of the project, including what is in scope and what is out of scope? What data is available or can be collected? And in what form do I want the results? So those are all things that are generally reflected in a functional specification. And a functional specification basically describes what should be delivered, when, how, and by whom. It's a way of telling you how, or giving you information to determine how long the project will take. How long will the project take? Well, this is one of my favorite cartoons. I need a budget estimate for the project, but I don't have a functional spec for it yet. All right, here's an estimate. But how'd you give me that estimate? You don't know anything about my project. Well, that makes two of us because you don't either. So until you've done a functional specification, you don't know anything about a project. And you can't give any estimates. And that can be a problem because everybody wants to know how long a project is going to take, and we do that all the time at Simio. We say, well, what feature do we want to put in? How do we want to rank these features? Things like that. Well, without knowing cost, I can't rank a 2-hour feature against a 2-week feature. So it is important to have some estimates of that, but it's more than just cost. It's estimates of when we can do it, how much effort it's going to take, what kind of things are in scope, out of scope, things like that. So it is really important to do a functional specification. And a lot of people resist this. A lot of people say, well, no, I don't have the time. I recommend 5 to 10% of the estimated total time should be spent developing objectives in the functional specification. And a lot of people say, well, no, I can't do that. And if you think about it from a stakeholder perspective, it is rare, almost never, that somebody comes to me and says, hey, I need you to build this model, take your time, get it done whenever you can. Instead, they're saying, hey, I know this model is probably going to take you 3 weeks worth of effort to build, but I need the results on Monday, right? So every model is already, behind, it's late when it started, essentially. I'd say almost all models fit into that. And so if you say, okay, well, the first thing I'm going to do, I think this project's going to take 2 weeks. So the first thing I'm going to do is spend a day doing a functional specification. The customer is generally going to say, oh, no, we don't have time to do that. Well, if you don't have time to do a functional specification, you don't have time to do the project. When do you want to find out that that 2-week project is actually going to take 4 weeks? Would you rather find that out on day 1 or day 20? And so it's important to do this. And I submit that it is not extra time. All of the things in the functional specification are things that you need to do before you can complete the project. So rather than just working on it and doing these things at the end, bring these selected important work to the very beginning of the project where it can be used in planning and estimating the work. And that doesn't matter if it's a 3-day project or a 3-month project, you still need to do that functional specification. Okay, simulation projects, lots of people describe them in different ways. You can describe it graphically, but basically it is going through developing the objectives, understanding the system, looking at scope and modeling detail, collecting the data, building the model. And note the arrows in here, all of this is iterative. You do a functional specification, you do a prototype to make sure everybody understands the functional specification, and guess what? They don't. And so by doing this prototype, we've learned something. Sometimes you have to go back all the way to set new objectives. Sometimes it's adjust the functional specification, and then you build the model. And then build the model, get input data, validation, verification, often go through that loop many times, and then go into my experimentation of the validated model, report results. And again, sometimes at this time you say, hey, that isn't at all what I expected, which is okay. I learned something from the model that I didn't know. So now I need to go back and revisit my objectives and functional specification for phase 2 of the model. Project iterations. You must do iterations. A lot of people will start modeling and just keep adding to the model that's complete and then run the model. Don't do that. The iterative model building process, add some features, run and test, and then repeat. I don't think I ever work more than 2 hours without going through this cycle. And often it might be 30 minutes. Every 30 minutes I go through the cycle. I really hate losing stuff. And although Simio is probably more robust than most other products, Simio still crashes from time to time because it is very complex software. And when it crashes, I don't want to lose my model. I don't want to lose the last 8 hours that I've done. Or if I find that I've taken a bad approach to something, I've spent the last 4 hours doing something that didn't work out, I don't want to go back and start over again. I want to go back to where I was and rebuild from that point. So the more iterations you have, the better. Some of the common pitfalls, not understanding the purpose up front, too big or too complex model. You want to start with something small. Every project should be done in phases. And the phase one should be an easy win, the smallest thing that you can do that provides some meaningful results. And then you can always do phase 2, phase 3, phase 50 if you need to. Not counting for variability is often done. I don't know how many people have said, oh, my system doesn't have variability. And then I model variability in it anyway, and they say, oh, wow, I didn't realize it had that much effect. Obtaining the necessary data, that's something that a lot of people have problems with or anticipate. You know, they think the data is available, but it's often not as available as it is. When I quote a fixed time project, which I actually prefer doing, and the customer supplying the data, I always peg my delivery dates in terms of when I receive the final data. So I might say, well, I can do 3 weeks worth of work while you're gathering the data. And then after I get the final data, then I need another 2 weeks to finish it. Well, if they take 8 weeks to give me the data, I'll still finish it 2 weeks after I get the final data. Verifying, validating the model is a really important thing. Basically, it's making sure that the model does what you think it does, and so that you haven't made any errors, and then also is realistic enough to the real world to be useful results. And again, it doesn't have to be perfect. It needs to be close enough to provide value. Okay, we are really close to the end of time here. So very quickly, I just want to talk about a few things in Simio. So on the support ribbon in Simio, there's a lot of information, and you may have gone there already to get the book that we're going to use in one of the coming sections, or to look at examples. But there are lots of SimBits there. And SimBits, there's over 200 small example models that are completely documented that tell you how to do certain things. So if you said, well, hey, I want to, tie 2 servers together. Well, you can find a SimBit in there that does those. So I would look for those, look under the video, look under the training. There's lots of really valuable information here, not the least of which is the help, which is about 1,500 pages of help if you were to print it. I don't recommend it. If you go to this help button here, it has a very searchable help that will take you directly to the right place. So it's context searchable help. The last thing I just wanted to mention is that there's lots of training materials available. There's lots of different books in various different languages. And in particular, I'd like to bring your attention to, we have 3 online courses. The fundamentals course, which we're doing about the first 20% of the fundamentals course we're covering today. Then there's an advanced course and the fundamentals of risk-based planning and scheduling. So those 3 courses, actually up until a couple of weeks ago, they were $2,000 a piece. So we just reduced that price when we came out with a learning Simio suite. By the way, each one of these represents roughly a 4 to 5 days worth of live training if you went to it as a live training. You can also get a learning Simio suite, which contains all 3 of the above, and all of those are available with the code that was sent out ahead of time for the course prep. There's a code there that will give you 50% off any one of those 3 or 4 courses. So even if you want to get the whole suite, and that's good for a year. The code is actually only good for a few weeks, but the course is good for a year. So once you sign up for it, you can take it as many times as you want, look back to it, anything you want for a full year. Okay, so that's the end of this section, and I almost made it on time, which is amazing for me. So I will take questions now on this section, but I will also say that we will break now for, I think we have, what is the?
We have 45 minutes until 1 o'clock. Yep.
Right. Okay. So we're going to talk into the break time. So anybody who wants to just go, that's fine, and get your lunch. But if anybody has any questions, I'd be happy to take questions during my lunch.
Folks, so if you have any questions, please feel free to unmute yourself and then ask the question. And then also we have a couple of questions in the chat box. Let me start off over there, Dave.
Okay.
So I have one question from Samuel Infante. So is there a background saving procedure for the Simio software similar to tools such as Microsoft Word? It would be pretty painful to have worked on a big simulation project in industry and have it all not saved.
Okay, what was the first part? Is there a backup procedure? Is that...
Yeah, so I think what Sam is asking is there a way for Simio to automatically save the model while working on the simulation? Because usually it would be pretty, painful to have worked on a big simulation project without saving it automatically.
Right. So there are automatic saves as part of it. So every time you exit Simio, it saves a backup copy. There is an option for every time you run Simio to save a backup copy. You can also save whenever, on demand, of course, you can save. There's also multiple ways of saving. So the normal way of saving is, and lots of people don't know this, but Word files, for example, are stored as a compressed XML file. And Simio also, the standard way of saving is as a binary that is a compressed XML file. However, if you want to save the components of that, you can save the components of that, basically the XML files themselves, which works very well with source control. So binaries don't do well in source control because let's say the model is 2 meg. Every time you save it, it's another 2 meg image. But if you do save it as an XML file, or save as a project, I think is the formal option, then it will allow you to save it and commit it to any kind of a source control program easily.
Okay, thank you. Sammy, we hope that answered your question. I have another question from Oscar in the chat box. So he says, what is the difference between a prototype and the model?
Okay, so that was in my discussion of functional specifications. Generally, Simio is pretty easy to do prototyping because of the drag and drop. Often what I would do, and you could take it as far as you want, but typically I might have a 1 or 2 hour discussion with a prospect where he starts describing what he wants. And I might, as a result of that meeting, I might spend an hour or two building a prototype of the model to say, hey, this is a high level viewpoint, doesn't have all the details, it won't produce useful results, but it's a high level viewpoint of my understanding of your model. And often the customer will say, oh, well, this part of it, that is exactly what I had in mind. But this part over here, we didn't communicate well because I need this done in a different way. And so that's the value of a prototype. It helps everybody reach a common understanding of what's going on. Now, when I talk about prototypes on projects that last a small number of days or weeks, I'm usually thinking of a small number of hours for a prototype. Sometimes we have projects that we anticipate to run many months long. And in those cases, we might spend a week doing a prototype just to make sure that we're all on the same page.
Thank you.
Thank you, Dave. And folks, do we have any other questions before we head to lunch break? And we will be back around 1 o'clock at 1 p.m. today at Central Time. Looks like we don't have any other questions, Dave. Well, before we leave, I have a question. So in terms of running replications, right? So are there any based on your insight, is there any direct proportional relationship into getting results at a transient state of the system in terms of running replications and the number of objects that we use for simulating a model?
I don't think the replications is dependent on objects. The main thing, and this is hard to estimate, but the main thing is how much variability is in the system. And so if we take an extreme case that is totally deterministic, there is no variability at all, and that doesn't happen often. But in that extreme case, you only need one replication because every replication will generate exactly the same result. In a more typical case, if you have, let's say, typical variability, if there is such a thing as that, then we recommend starting with somewhere in the range of 10 to 25 replications. And in most systems, you tend to get declining returns after you get to 25 replications. Now, that is most systems, not every system. Particularly small models with high variabilities that are often done in academic environments. In those situations, you might need hundreds of replications to get to the confidence interval you want. But I would say in more typical commercial models, you know, I would generally start with 10 and see what your confidence intervals look like. And then based on those confidence intervals, add 10 more or 20 more or 30 more.
Okay, thank you. Thank you for the clarification.
Sure. Any other questions? Okay.
Looks like we don't have any questions. So let's all take a lunch break and then we'll be back again here at 1 p.m.
Okay.
Thank you guys. And thanks, Dave.